In this video, we will review the properties of similarity. Mostly we will be working with similar triangles, but maybe another shape will show up. So in problem number 1, we are given the triangle ABC is similar to triangle FED. And we're supposed to find the values of x and y. Well, we have a big triangle and a small triangle, so obviously the sides are not congruent, but what they are is proportional. So, let's see, side ED, alright, see the ED right there? That's going to correspond with side BC. So, ED corresponds with BC. So it's critical to match up the corresponding sides. Okay, what else you got? Okay, I've got this 12 over here that I'm going to need. That's side DF. Okay, so that's DF. So that's going to correspond with AC. So the 12 corresponds with the 15. So when I make my fractions, I'm going to keep this in mind. I'm going to make a fraction out of the yellows, and I'm going to make another fraction out of the blues. So for example, I might do x over 18. Okay, so I'm using the right triangle over the left triangle. And then I'll have to do 12 over 15. Got to do it the same way. Now I like to reduce when I do these. Both of these are divisible by 3. So let's see, x over 18. 3 goes into 12 4 times, 3 goes into 15 5 times. And then we cross multiply. So looking at this diagonal, I have 5x. And looking at this diagonal, well, I don't happen to know what 4 times 18 is off the top of my head. So 72. And then I would have to divide both sides by 5. So that's 14.4. Now let us find y. Okay, y, that's EF. Okay, so EF is going to correspond with AB. So those go together. Okay, so I will make a fraction out of the greens. So I will go y over 9. And then I'm going to go back to the blues here. So this will be 12 over 15 again. Okay, great. So y over 9 should equal 4 over 5. I'm just reducing again. Along this diagonal, I have 5y. Along this diagonal, that multiplies out to be 36. And I divide both sides by 5. And 36 divided by 5 is 7.2. Problem number 2 is almost the same, but the order of the letters in the similarity statement have changed. So x is ED. Okay, so here's E and here's D. So that's going to correspond with AC. Alright, so this time these are corresponding sides. Okay, now I've got this 12, which is DF. So here is DF, so that's going to correspond with BC. So these are going to go together. So I'm going to make a fraction out of the yellows and a fraction out of the blues. So I will go x over 15 is equal to 12 over 18. So I've got x over 15 is equal to, both of these are divisible by 6. So this will be 2 over 3. So this diagonal gives me 3x. This diagonal gives me 30. So if I divide both sides by 3, I get x is equal to 10. Okay, now I need to go back and deal with the y. Y is EF. So here's EF, so that's going to correspond with AB. So now I will make a fraction out of the greens. So that would be y over 9. And I'll go back to the blues because it's all numbers. So 12 over 18. So y over 9 is equal to 2 over 3. This diagonal gives me 3y. This diagonal gives me 18. If I divide both sides by 3, I get 6. Alright, I need to find x. So I'm looking at QR. QR is going to correspond with TU. So those are corresponding parts. Okay, and then I look back at the same triangle and I see a 12. That is PQ. So here's PQ, and that's going to correspond with ST. So there's ST. So those are corresponding parts. So I'm going to make a fraction out of the yellows and a fraction out of the blues. So I could go 5x plus 4 over 15. That's the yellows. Then I will do 12 over 8. Okay, let's see. So I've got 5x plus 4 over 15. Now I'm just reducing this. Both of these are divisible by 4, so this will be 3 over 2. So if I multiply this diagonal, then that means 2 times 5 plus 5x plus 4. 3 times 15 is 45. Distributive property now gives me 10x plus 8 is equal to 45. Alright, I'm running out of space here, so I'm going to make a new column. If I subtract 8 from both sides, so that's going to be 37, so I'll have 10x is equal to 37. Alright, if I divide by 10 on both sides, that's going to give me x is equal to 3.7. So now I need to find y. Okay, so y is part of this expression right here. Alright, so I'm looking at angle P. So I'm noticing that angle P corresponds with angle S. Okay, so I need to know what angle S is. Okay, so I guess I need to play around a little bit. So we're given the value for angle R. Let me erase some of these colors. Alright, notice that angle R corresponds with angle U. So if angle R is 28, that means angle U is also 28. That gives me 2 out of 3 angles in this triangle. So I can easily subtract from 180 to find the other angle. So if I do 180 minus 28 minus 64, that's 88. So that means that angle S is 88. Okay, now, like I was saying a minute ago, angle P corresponds with angle S. So that means that angle P and angle S are congruent. So that means that the 4y must equal the 88. So 4y must equal 88. So to find out what y is, I have to divide both sides by 4. So that's going to give me 22 for y. Number 4 is a very fun problem because I can find x and y in two different ways. When I have parallel sides like this, I can use the Side-Splitter Theorem. So I'm sort of viewing the parallel lines as the base of two triangles. That would make these the sides. Alright, this would be the side of the big triangle, and this would be the other side. Alright, I'm picturing this as sort of lying on its side. Anyway, you cannot use the Side-Splitter Theorem to find the parallel sides. Anyway, the Side-Splitter Theorem tells me that I can make a fraction out of the x and the 12 and the 6 and the 10. And those should be equal. These are proportional. So, for example, I can write x over 12 is equal to 6 over 10. So that means that x over 12 is going to equal to 3 over 5. And now if I cross multiply, that's going to give me 5x from this diagonal and 36 from this diagonal. Alright, and then I'd have to divide both sides by 5. Alright, and that's 7.2. So x is 7.2. Alright, now I can't find y that way. This Side-Splitter Theorem does not work for the parallel sides. So when it comes to the parallel sides, I need to draw these two triangles separately. Alright, so I've got the smaller triangle, which goes like this. And then I've got the larger triangle, Alright, so a problem like this, you have to deal with the two triangles separately when you're dealing with the parallel sides. So the smaller triangle, this side is y, and this is 12, and this is 10. Now the larger triangle is somewhat trickier. This side is 24, that's the easy part. Now this side down here, what is it? I'm hoping you can tell this is 16 because I had to do the 10 plus the 6 together make the large side. Now I'm not actually going to need this side, but if I were going to write it, it would be 12 plus x, or I could have said x plus 12. But we already found x using the side splitter, so I don't really need it right now. So instead, I'm just going to make a fraction out of the y and the 24, and I'm going to make another fraction out of the 10 and the 16. Okay, so I'm going to have y over 24 is equal to 10 over 16. So that's going to make y over 24 is equal to 5 over 8. And when I cross multiply, I have 8y is equal to whatever 5 times 24 is, 120. And then I have to divide by 8. And that's 15. Alright, for number 5 we can use the angle bisector theorem. Notice that these two angles are congruent. That means we have a bisector happening. Now, even though these two smaller triangles that are created are not similar, there's something that will be proportional. First of all, we need this missing side over here. So obviously this must be 10, alright, 16 minus 6. So the angle bisector theorem says that these segments are proportional to these segments. So if I make a fraction out of these, and I'll just keep it kind of in the order that it's in, that would be 6 over 15. And if I make a fraction out of these in the same way, that would be 10 over x. These are both divisible by 3, so that's 2 over 5 is equal to 10 over x. Multiplying this diagonal gives me 2x. Multiplying this diagonal gives me 50. And of course, when I divide both sides by 2, that gives me x is equal to 25. Okay, now over here we have these parallel sides. We can do the side-splitter theorem, similar to the way that we found x on problem number 4. I made a fraction out of these, and I made a fraction out of these. Okay, that was the side-splitter theorem. You can do something very similar for problem number 6. But first, we need to know what this missing piece is right here. And of course, that's going to be 10, right? 16 minus 6 again. So, according to the side-splitter theorem, these segments will be proportional to these segments. So I can just make fractions out of these. So, for example, I can write 4.2 over x is going to equal 6 over 10. So that's 4.2 over x is equal to 3 over 5. Multiplying this diagonal gives me 3x. Multiplying this diagonal gives me, I don't know, 4.2 times 5. What is it? That's 21. Oh, that works out nicely, because then when I divide both sides by 3, I get x equals 7. For number 7, we're going to use something called the Mid-Segment Theorem. That looks stupid. Mid-Segment Theorem, you know what I'm saying. These tick marks tell us that D and E are midpoints. That makes DE a mid-segment. And the thing is, we have learned that the mid-segment is going to be half of this parallel side. So, if I were to double the mid-segment, if I took DE and I double it, then it should equal the parallel side BC. So in other words, if I double the 3x plus 15, that should equal the 9x plus 3. That's how mid-segments work. So a little distributive property here gives me 6x plus 30 is equal to 9x plus 3. And then I would subtract 6x from both sides. And so we'll have 30 is equal to 3x plus 3. Then I would subtract 3 from both sides. So that's going to give me 27 is equal to 3x. Then I would divide both sides by 3. And that's going to give me x is equal to 9. Alright, now for number 8, let's complete a similarity proof. Okay, now there are 3 ways to prove that two triangles are similar. Did I say 3? Maybe there are only 2. There's angle similarity, and there is side angle side similarity, and there is side 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 similarity. Okay, that's it. Those are the 3 methods of proving two triangles are similar, nothing else. Anyway, let's see what it turns out to be. So we are given that DE and AB are parallel. Notice they're not congruent or anything, they're just parallel. But parallel lines lead to congruent angles. Either we can draw a Z, and that's alternate interior angles, or we can make an F, and that'll be corresponding angles. So I'm looking at angle A, so I'm going to really focus on that as I draw my Z. Okay, so there's my Z. So when the top and bottom of the Z are parallel, then the angles in the corner are congruent, and these are alternate interior angles. So that means angle A is going to be congruent to angle E, and the reason is the alternate interior angle theorem. Okay, and that's just the theorem that says if the lines are parallel, then the alternate interior angles are congruent. But this is a shorter way of saying that. Then they mention angle BCA. BCA. Well, that's one of our vertical angles. So that should, of course, be congruent to the other vertical angle, which is angle DCE. So angle DCE. And the reason would be because vertical angles are congruent. Now, that gives us enough information to prove that these triangles are similar because of angle-angle similarity. We have two pairs of angles. So we can go ahead and say that triangle ABC is similar to triangle, let's see, ABC, so that'll be EDC, by angle-angle similarity. All right, don't forget the little similarity symbol that goes at the end. Now for this last problem, in order to solve this problem, I need you to understand how the ratios of lengths, areas, and volumes compare when you're dealing with similar figures. So imagine that you have lengths that are in the ratio of x to y. Then the way the ratio of areas would be x squared to y squared. And the ratio of volumes would be x cubed to y cubed. So just as a quick example, maybe I'll change colors. Let's say I told you that the lengths, and this would apply to perimeters as well, because perimeters are just lengths. The ratio of lengths, if I told you, was 2 to 3. Then the ratio of areas would be 4 to 9, because that's 2 squared and 3 squared, 4 to 9. Okay, so that led to that. And the ratio of volumes would be 8 to 27. Now notice I'm not getting this from the 4 and the 9. I'm going all the way back to the lengths still, because the volumes are x cubed and y cubed, and this is x and y. 2 cubed is 8, and 3 to the third power is 27. Alright, so that's how it works. So let's see what we have. Two cylinders are similar. The smaller cylinder is 14 inches tall, and the larger one is 21 inches tall. So right there, they're giving us the ratio of lengths. Okay, think of it as a length scale factor. Okay, so they gave us 14 to 21. All right, so I have 14 to 21. So that's the length scale factor. However, it would be much more convenient to reduce this. If you think of the ratio as a fraction, like 14 over 21, and we need to reduce this, you might notice that both of these are divisible by 7. So that's going to give you 2 to 3. So that's really the ratio that you're going to end up using, will be the ratio of 2 to 3. Alright, so that is the ratio of lengths, is 2 to 3. So that means the ratio of areas, or the area scale factor, oh wow, this is the one, these are the numbers I just picked a minute ago, just at random. So yeah, this is going to be 4 to 9, like we discussed a minute ago, and this is going to be, again, 8 to 27. Alright, 2 squared and 3 squared, and this is, going back to the 2 and 3 again, 2 cubed and 3 cubed. Okay, now we should be able to do the rest of the problem. Alright, if the smaller cylinder's volume is 400, okay, so this is the small volume. What is the larger cylinder's volume? Okay, so the trick is set up your equation in the form small over large is equal to small over large. Okay, so we're given the small volume, 400. So I'm going to do 400 over, well, large, which is what we're looking for. So we're just going to call that x. Alright, but that's small over large, 400 over x. And we're going to set that equal to one of these three scale factors. Are we going to use the length scale factor, the area scale factor, or the volume scale factor? Well, we're talking about volumes, so obviously we're going to use the volume scale factor, which is 8 to 27. Alright, so 8 over 27, small over large. So that's how you make the equation. And then you just cross multiply like you've done 1,000 times. So along this diagonal, I'm going to have 8x. And looking at the other diagonal, I have to do 400 times 27. So that is 10,800. And then of course, I need to divide both sides by 8. $1,350. So now would be a good time to put the units back in here. So we're talking about inches and cubic inches. So that's going to be cubic inches because it's a volume. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.